In this example, we want to graph a quadratic equation, also known as a parabola, using the vertex formula. Once again, so I think the vertex formula is the easiest way to graph things. There are other ways, but vertex formula to me is the way to go. So let's bring up the vertex, or let's bring up the method for doing this here. There we go. So the first step here is, does it open up or down? Well, we have our a term here. A is greater than 0, so it opens up. That's good news. Next step, vertex. X equals negative b over 2a. So negative 12 over 2 times 3, negative 12 over 6, negative 2. That's just half the vertex. The other half is the y value. So we plug in negative 2, f of negative 2, plug it back into this original function here, so I'm going to get rid of, well, I'm going to leave that there. 3 times negative 2 squared plus 12 times negative 2 plus 16. Well, negative 2 squared is 4, 3 times 4 is 12, so 12 minus 24 plus 16 is 4, positive 4. So that gives us a vertex of negative 2, 4. Now, something's already up here. We could actually be done with this problem right now, essentially, other than we haven't done the graph, but let's draw our grid here. We can plot our vertex, negative 2, 4. There we go. If we use the fact that this thing opens up and the vertex is up there in quadrant 2, then we can deduce that there's no way it can have an x-intercept, right? I don't know quite what this looks like, but I know it opens up somehow. There's no way for that to have an x-intercept. So if you see that, feel free to go right for the last thing, which is our y-intercept here of 16, right? It's always that constant term. So this was 4 here. So I'm just going to have to kind of abbreviate this a little bit, but let's say 16 is up here, right? And that makes us a nice parabola like so. Using the symmetry, we get a second point here at negative 4, also up at 16, right? Every point on a parabola, you get another point for free. That's not my best looking parabola, but it'll have to do. Okay, so you can just go straight there and graph it. So we've done the vertex. Well, we didn't really think about the x-intercepts, we did the y-intercept. Now, if you don't see that, sometimes you're just engaged with the problem. You don't do that reasoning to say, oh, the vertex is here, it opens up. Let's see what would happen, right? If we solve this for x, we would get 0 equals 3x squared plus 12x plus 16. Right? And then we'd spend a bunch of time trying to factor it, only to come to the conclusion that it doesn't factor. Okay, what do we do when it doesn't factor? Hit it with the quadratic formula. So x equals, remember this, negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, well, a, b, and c. And I'm not going to evaluate this all the way out. I'm only going to look at this radical here. We call this the discriminant, because if we can get a negative inside here, actually the b squared minus 4ac is the discriminant, but if we can get a negative inside that radical, we know there's no solution. So we have b squared 144 minus 4 times a3 times 16. Okay, so that's square root of 144 minus 192, turns out, which comes to negative 48 inside the square root. So this, if we were to evaluate it all the way out, this is going to give us imaginary solutions, or at least complex numbers for this. But we're graphing in the real number line here. So if we get complex results and imaginary numbers for our x-intercepts, we know that there are no x-intercepts. So we could have also concluded it from here. No x-intercepts. So even if you don't spot that there's no x-intercepts, you'll figure it out when you go to solve for the x-intercepts.